5.5 making connections, exponential models. So we did talk about this model. The n is number of the population or the number after time t. N0 is initial, e is the base, the power is negative lambda t. Now, here if we have half-life, guys, you know n is going to be n0, 1/2 t divided by h. Here, the h is the period of getting half, or the half-life is a time. H is a time that take for material to decay to the half of the original ones. Both of these equations working, let's say, look at that, NT6 e power negative 0.27 t, or 1/2 t divided by 2.6. They just have a different representation, different exponents. 1/2, and here's e. Next question, we want to see how we can convert them to each other. Let's just do that. 6 milligram sample of the AU198 is injected into the liver, then decays to 4.6 after 1 day. So if I want to go with the exponential model with the base e, so this is the general equation that I have. So n is 4.6 after time, t is 4.6 after 1 day. The t is 1, and initially it is 6 milligram. I need to rearrange for the exponent. I divide both sides by 6, and you put the ln in front of both sides. The negative lambda come in front. Ln of e is 1, that's why you don't see that here. And you just divide both sides by -1. This is what you put in calculator. Lambda, we will get this number. Now we have our model, which is n is equal to n0 e power negative lambda. If we have n0, we have 6. Lambda, we got it 0.266 from previous part. Now, is it determine the half-life? Means when we want to find the half-life, means the time that the initial amount getting half, right? So if this is 6, after what time you're getting half of that? Half of 6 is 3. That's why you see 3 here. Divide both sides by 6, you get 1/2 here. Again, you want to rearrange it for exponent. Put the ln in front of the both sides. Power get in front, and ln e will be 1. You rearrange it for t here, 2.6. This is the half-life. Now, equation of give the amount of that in terms of the half-life. It's going to be, this is a general equation that I have for half-life. N0 is 6 t over h. I know half-life, again, is the amount of the time that it takes for one material to decay to half of original. We got that time in the previous step, which is 2.6. Is that t divided by 2.6? This is going to be the equation of the half-life. So for the worksheet, you can do question number 1, question number 2, 4, and 7.